Now we're going to look at right triangle trig. So there's a trigonometry that's involved with right triangles as well as with circles. And in this case, the angle that we're going to talk about is going to be this angle T down here. This is a right triangle. This is the right angle. So the other two angles, T and this angle up here, add up to 90 degrees. So we have the complete 180 degrees in a triangle. We have a base here, call that B. We have a height here, or let's say altitude A. And this H is the hypotenuse. So I have a hypotenuse. And then when I'm talking about angle T, A is the side opposite T. So this would be the opposite side. B is one of the legs of the angle, and so B is the adjacent side to angle T. And we can write all 6 of our trig functions in terms of opposite, adjacent, and hypotenuse, depending on which function we have. So if I take the sine of angle T, that ratio, no matter how big the triangle, the length of the sides, my angle T for the sine is the opposite side divided by the hypotenuse. That ratio is always true for angle T and the sine of it. For the cosine of T, it is adjacent over the hypotenuse. We can find a lot of information from this if we actually have 2 sides of a triangle. We can find our angle T, we can find the third side, we can find not just sine and cosine, but we'll be able to find everything else. Remember that tangent is sine over cosine. So if I have the tangent of T, it would be the sine opposite over hypotenuse divided by the cosine, adjacent over hypotenuse. And if you think about taking the denominator, invert and multiply, these denominators go away, so the tangent of the angle is actually opposite over adjacent. Now, you can memorize that, but with a lot of these others, I just recommend no sine and cosine and get the other angles, the other functions from that. Cotangent then would flip adjacent over hypotenuse. From sine, we get secant, which would be hypotenuse over opposite. From cosine, did I say secant or cosecant? From sine, we get cosecant. Hypotenuse over opposite. From cosine, we get secant, hypotenuse over adjacent. So everything comes from sine and cosine. You don't really have to learn a whole lot more. Just remember the other relationships with tangent being sine over cosine and so on. Everything goes back to sine and cosine. Now, let's look at a particular triangle. Let's say we have 2 sides, and that is usually what happens with this type of trig. When we look at the right triangle trig, we're given 2 sides. So let's say, what do I want this time? All right, let's take side A, and let that side A be 7 square root of 3. And let's let side B, the base, be equal to 7. Okay. And what I want to do now is find all 6 of my trig functions. So if I'm finding the sine of T, it'll be the opposite side over the hypotenuse. 7 square root of 3 on top over the hypotenuse. Well, I don't have H yet. Well, I need the hypotenuse for cosine. So I think we probably need to find the hypotenuse. Now, because this is a right triangle, what we can do is use the Pythagorean theorem that says the hypotenuse squared is the sum of the squares of the other two sides. So I have 49 plus 49 times 3. Remember, you square each piece. I add those up, and this ends up to be, I think, 196, which gives us a hypotenuse of 14. Take the square root of that to get the hypotenuse. So up here, I have 7 squared of 3 over 14. Now I can reduce that because the 7 can divide into the 14, and that gives me square root of 3 over 2. For the cosine, I do the adjacent over the hypotenuse. So the cosine of t would be the adjacent side 7 divided by the hypotenuse 14. Well, that's just a half. So let's do tangent next. Tangent of t, we found out we could just do opposite over adjacent, so we can do that. This is t, that's the opposite side. 7 root 3 over the adjacent side, 7, just gives me root 3. So I have found those 3, and now my remaining 3 just come from these. So if I want cosecant of t, it's the reverse of this, which would make it 2 over the square root of 3. If I want secant of t, that comes from cosine. Flip that, I get 2. And if I want cotangent of t, this would be 1 over square root of 3. So these 3 come from these 3. These are the 3 major trig functions, and these are the 3 minor trig functions. So I can get all of that from a triangle if I know 2 sides. Well, let's look at another triangle and see what we can come up with. Let's see. Let's say we're given C, or H, hypotenuse. Get those off of there. Okay. So say this is 4 square root of 2. And let's let A be 4. So I don't have B. And let's not find everything. Let's just find sine and maybe cotangent. Now, if I'm looking for sine of angle T, the sine we said was opposite over hypotenuse. Well, I've already got that. I've got the opposite, I've got the hypotenuse. So I could go ahead and put that in. The sine of t is 4 over 4 square root of 2. Well, the 4 is reduced, and that gives me 1 over square root of 2. Oh, that was easy. I didn't even have to find b. Cotangent of t. The cotangent of t, let's go back to basics. Cotangent is cosine of t over sine of t. Cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. So this is going to be adjacent over opposite. Well, I've already got the opposite is 4. I know what goes in the bottom of this one. So the cotangent of t here on the bottom would be the opposite side 4, but I don't know the adjacent side b. I need to find that. So what I'm going to do is find the adjacent side, and then I'll know what to put in the numerator of my cotangent. And to find the adjacent side, I go back to Pythagorean theorem again. So the hypotenuse squared, that's 4 root 2 squared, is equal to b squared plus 4 squared. Here, 4 4s are 16 times 2 is b squared plus 16. So I have 32 minus 16 gives me 16 over here equal to b squared. So b is equal to 4. Whoa, b is the same as a. Okay, so I have 2 sides that are equal. So my numerator here is 4 because we found that side b is equal to 4. So my cotangent of t is equal to 1. So with any two sides, we can do this right triangle relationship to try to figure out all the different trig functions. And I could even figure out the angle t if I wanted to go and see, use your calculator and use an inverse sine, or inverse sine would be the best one to use on a calculator. If you're looking on a calculator, which we'll be doing in a minute, remember that if you're working with degrees, be sure the calculator's in degrees. If you're working with radians, be sure it's in radians. Okay? We're looking at right triangle trig again, but this time we're going to look specifically at some triangles that are 30, 60, 90 degree triangles, or are 45, 45, 90 triangles. In the lesson, they show you different relationships for those particular triangles between the sides and the hypotenuse, but we can also work the same types of problems using a method with just the basic right triangle trig with the opposite and adjacent sides and the hypotenuse. So let's look at this problem here. I'm given one side and an angle. Now the side happens to be the hypotenuse, it doesn't matter. I just need one side and an angle. And if I have that, I can also do just the right triangle trig. Now, the angle that I have is up here, and if I want to find B is the side opposite here. So if I have the opposite side and the hypotenuse, opposite over hypotenuse would be the sine of our angle, which is 45 degrees. So let's work with that. Sine of 45 degrees is equal to the side opposite, which is B, over the hypotenuse, which is 125. So the side B will be, if I multiply across, 125 times the sine of 45 degrees. Well, the sine of 45 degrees is in that table that you're supposed to have memorized in an earlier lesson. Various ways to write it. The sine and cosine of 45 is 1 over square root of 2, or you could write it as 2 square root of 2 over 2. This is fine. And so B is equal to 125 divided by the square root of 2. You want to put those together. So that's what our B is equal to, what this side is. I was not asked to find the height. I could do that. I could find that side also. But this is all we need for this problem, and I used the same method as before. Let's look at another one. Okay, I turned this one around just for the fun of it. And I'm using 60 degrees in that other triangle instead of 45. Be a little bit different. And here I want to try to find H and B. Now, I'm given the opposite side here. I don't know the hypotenuse, I don't know the adjacent side, but opposite side lends itself to sine. So my sine function, sine of, I'll just say of t in general, is opposite over hypotenuse. In this case, the sine of 60 degrees, the opposite side is 12 over the hypotenuse. Opposite over hypotenuse, I don't know the hypotenuse. That's what I'm looking for. So I can multiply it over here, h times sine of 60, and then I can take my sine of 60 and divide. So this will give me what h is equal to. Well, sine of 60 is one of those in the table, again, that you're supposed to have to remember. The sine of 60 is square root of 3 over 2. I can remember that because the sine of 30 is the little angle and it's a half, so the sine of 60 must be root 3 over 2. So how are we going to simplify this? Well, I'm dividing by a fraction, so I can invert the fraction and multiply by it. So this gives me 24 over the square root of 3. Perfectly good number. So I have found h. So h is 24 over root 3. Now I need to find b. Well, a couple of different things you can do here. I can go back and use, since b is the adjacent side, I could use cosine of 60. Let's put that one up here. If I do cosine of 60 degrees, that would be adjacent over hypotenuse. So I could use cosine of 60 is b over 24 over root 3. Solve for that. I could use Pythagorean theorem. That's a perfectly good way to do this. Pythagorean theorem here. Let's see what happens. We've got a root 3 in the bottom, so we haven't really looked a lot with that in the Pythagorean theorem, so let's try that. This is one of our possibilities where I would have the adjacent side, I don't know, over the hypotenuse, I do know. But now let's also say, let's just try Pythagorean theorem. So h squared is equal to 12 squared plus b squared. Okay, well, 24 squared. Do I remember 24 squared? Probably not. Let's see what that is. I know it ends in a 6. 6 something over 3 minus, I'll get there. I know that 12 squared is 144 equals b squared. So I can solve for b this way if I could remember how to multiply 24 times 24. So this would give me a value for b squared. I'd take the square root, I'd have a value for b. I actually can remember the cosine of 60, so that might even be easier. If I do that, let's just see. You can choose. Cosine of 60, well, this probably won't be easier. Cosine of 60 is actually a half. Let's go down here. Is b over 24 over square root of 3. Oh, you know, that looks shorter. Okay, let's see what happens here. I have a half. I multiply this over here exactly. And that gives me b. This is easy. 2 into 24 is 12 over the square root of 3, and that's b. Now, since I happen to know cosine of 60 degrees, and you're supposed to, this came out much slicker. I didn't have to square anything. I didn't have to square root anything. So we have at least 2, maybe more ways you can find this part. So a lot of what we do is, we can do it a way, you can do it a way, you get the right answer, you do it correctly your way, it's fine. So you can make your choice. Let's see, let's look at one more of these. Okay, now this right triangle, B is 27, and let's put my 45-degree angle right here. This is going to be another 45-degree angle. And I want to find A and H for this one. Okay. I have the adjacent side, adjacent. So cosine of t is adjacent over hypotenuse. So I'd have cosine of 45 degrees equals 27 over h. Oh, this is very similar to one we just did. So I multiply by h, and then I divide by the cosine of 45 degrees, and the cosine of 45 is 1 over square root of 2, like the sine of 45 was in a previous example. So my h value here would be, invert and multiply, 27 times the square root of 2. I have h. And I can get a, I think I will do a since that's the opposite side. I might as well do the sine. Let's go to a. And a is the opposite. I think I'm going to use tangent. No, maybe I better not do that. Let's go with this. Let's go opposite side is sine, excuse me. Sine of 45 degrees would be a over h. Just found the h. So A is 27 root 2 times the sine of 45 degrees, which is the same as the cosine of 45 degrees, 1 over square root of 2. So that gives me A. And the root 2's cancel, so A is 27. Again, there's several different ways you can go about finding your second term. I could have used Pythagorean theorem again here with the H I had and this one.